Okay, so just to confirm that the answer down here for the concentration of salt solution that caused the chip to gain mass is 0.1 moles, because it's the only solution where we had a positive change in percentage mass. Okay, then turning over the page. So the next question, we've got to complete the graph using the data from the table, choose a suitable scale and label, plot the percentage change, and then draw a line of best fit. So there's 4 marks available. So the first one comes from labeling correctly, concentration of salt solution. So for the x-axis, make sure that you got the unit, so capital M for moles, and then putting a sensible scale. So I decided to use 10 small squares to represent each 0.1 moles. And the reason I decided that is because it means that the numbers are going to cover the whole axis, so the points will be nicely spaced out. So that's going to get me 1 mark for a suitable scale and for the label there. Now the next 2 marks come from plotting the points correctly. So the first point, 0.1 moles, and then it's a change of +4. So if we look at the scale here, 10 small boxes represent a change of +5. which means 2 small boxes represent a change of +1. So if I go up 2 boxes, that's +1, that's +2, +3, +4. Then 0.2 changes 0, so the point is just right there. 0.3, the point is -4, so 2 boxes away from -5, there we are. Then for 0.4, it's -8, so go to -10, up 2 boxes, -9, up another 2 boxes is -8. And then finally for 0.5 it's a -11 change, so down to -10, and then down 2 more boxes is -11. So if you plotted all the points correctly, you get 2 marks. If you made a mistake with one, you get 1 of those marks, and if you made 2 mistakes, then you get 0. And then the 4th mark is for drawing a line of best fit, and in this case it looks pretty much like a straight line. The last point here is a little bit off, but it should be a straight line going through as many points as possible. Okay, now we've got some questions about the graph. So, first one, identify the concentration of salt solution in which chip should be kept in order to keep the mass constant. So, if you want to keep the mass constant, we want no water moving in or out. We want the percentage change to be 0. So there's only one solution where that was the case, and that's 0.2 moles. Now the reason for the answer is because at that concentration, at 0.2 moles, the percentage change is 0%. So that's how we know the mass would stay constant. Then the next question. So use your graph to estimate the concentration of solution inside the potato cells. Now the answer again is 0.2 moles. And that's because we're going to get no osmosis happening when the concentration of the solution is equal to the concentration of the potato cells. So here, 0.2 mole solution, there's no change in mass because no water has gone into the potato, no water has come out of the potato, and that's only going to happen when the concentration of solution matches the concentration of the potato cells. So that's why it's 0.2. One final question on this one. So the results in the table give us percentage change in mass, and we have to explain why we get results that are positive and negative. Okay, so there's 3 marks available here. So you can see that I've only got 2 bullet points. So first mark is for pointing out that we get positive percentages when the potato cylinders increase in mass. Second mark is where we get negative percentages when the potato cylinders decrease in mass. And then the third mark comes from giving specific examples. So 0.1 mole, that's the only time we get a positive percentage change, okay, because of the increase in mass. And then 0.3, 0.4 and 0.5, we get negative changes because of the decrease in mass. So to get the third mark, you had to actually say the solutions that are positive and the solutions that are negative. Okay, final question. So another one about an experiment. So a pupil sets up this investigation. They tie a thin membrane across the end of a funnel, put concentrated sugar solution in the funnel, put the funnel in a beaker of water, measure the level of solution in the funnel every 30 minutes. And here we go, we've got the apparatus, the equipment. So you can see I've already added a couple of things to the diagram because of what's going to come later on. So we've got water here. We know water has definitely got a high concentration of water, so we'd say that that's the dilute part of this. And then inside the funnel we've got a concentrated sugar solution, so I put the letter C. And then you can see I've done the arrow because dilute is going to move to concentrated, so water is going to move into the funnel, and that's going to cause the level to start rising up. So before we get to that question about what's going to happen, we have some questions about the practical. So the dependent variable, so remember that's what's measured, and the person is going to measure the level of the solution in the funnel every 30 minutes. So that's why I've just put level of solution. Then we've got two control variables. So remember, control variables, things that need to be kept the same. So you've got four options. So first option is that they're going to check the level every 30 minutes. So the key part of that is every 30 minutes. So to keep the test fair, they're checking how it's changed every 30 minutes, keeping the interval the same. Using the same funnel is important. Alright, so that's your second possible option. So making sure that they're using the same funnel each time they do this experiment. So it has the same volume, has the same type of membrane on the outside. Third option, keep the temperature of the water the same. So the rate of osmosis can be affected by the temperature of the water, so we must keep that the same. And then final option, keep the scale fixed in the same place. So gotta keep this ruler in the same place all the time so that we're measuring from the same starting point. Okay, that takes us on to our last question. So we see a graph of the results, and we're asked to explain. So after 3 hours, the level of the solution in the funnel is different from the level at the start. We have to explain why as fully as we can. So we're only interested in this 0 to 3 hour section where we can see the level of the solution has gone up. Now, we went through before why that should happen. So let's just recap it. So the water is dilute. Inside of the funnel you've got a concentrated solution, so water is going to move inside. So that pretty much gives us the explanation, except for a couple of key terms. So first point, water enters the funnel by osmosis, right? Key, you must mention that it's osmosis, that's the process. Second, through a semi-permeable membrane or a partially permeable membrane. Every time we mention osmosis, we can't forget to use that term. And then finally, the reason why it will move into the funnel, because the water is more dilute than the sugar solution. So it's going to move from the water into the concentrated sugar solution inside the funnel. So each of those points for 1 mark to get you the full 3 marks. Okay, that's the end of the osmosis exam. Thank you for watching.